What if I told you that 95% of the universe is invisible? You might think I'm talking about dark matter or dark energy, but actually it's even weirder. We can't see most of the stuff around us. Not trees, planets, or stars, not even space. So what can we see, and what does it all mean? Well, one man has dedicated his life to answering these very questions, and today we'll uncover them together. His name is James Peebles, and he's our hero for this episode. Stick with me. This is a story of how we came to know the cosmos. Alright, let's meet James Peebles. He was born in 1935 in Canada, which means that right now he's 87 years old. And don't worry, we checked. Being Canadian doesn't make him nice. He's actually pretty famous. In fact, he's been called the father of modern cosmology. But believe it or not, this guy didn't grow up dreaming of fame. He grew up dreaming of the stars. When he was young, Peebles would walk to the library and take out every single book about the universe. He read everything he could get his hands on. And it wasn't just because he loved rockets or spaceships or aliens. It was because he loved one thing and one thing only: asking questions. He wanted to know what we're made of, where we came from, and where we're going. At least that's what he says. In reality, he probably just really liked reading books. He got his bachelor's degree in 1958 from the University of Manitoba and his PhD from Princeton University in 1962. Then he became a professor at Princeton, and it was there that he started to answer some of the biggest questions in the universe. For example, remember the baby picture of the universe I mentioned earlier? Yeah, the cosmic microwave background. Well, nobody knew how to explain it until Peebles showed them how. Most physicists believed that the universe was static, which meant no beginning, no end, just infinite time. But by doing math, Peebles realized that the universe must have started with a bang. His predictions were published in 1965, and 4 years later, the first measurements of the cosmic microwave background were taken. These measurements confirmed what Peebles had predicted. The universe did start with a big bang, but Peebles didn't stop there. Remember that whole baby picture thing? Well, babies aren't the best at sitting still. And as the universe expanded, things started to move around. There was a lot of clumping and crashing, generally a lot of mess. Now, like any good parent, Peebles wanted to understand why. And so he started thinking about the early days of the universe. It's hard, it's dense, it's expanding. There's a lot going on. So let's add some music. By studying how light passes through clouds of dust, Peebles figured out how the baby picture of the universe became the reality we live in today. It took millions of years, but eventually things calmed down. The particles cooled, atoms formed. Gravity pulled those atoms together. Stars ignited, and galaxies spun into existence. But here's where things get weird. Remember how I said that 95% of the universe is invisible? Well, it's true, we can only see 5% of it. We call it normal matter. That's the stuff that makes up planets, stars, black holes, maybe even aliens. But we have no idea what the other 95% is made of. And there are two ways we're working to find out. First off, remember that baby picture of the universe I talked about earlier? Well, as the universe expands, it stretches that picture. And as it stretches, it creates something called the Doppler effect. Basically, the farther away a galaxy is, the faster it's moving away from us. So the light waves stretch and the galaxy gets redder. Scientists can use this information to tell how fast the universe is expanding. And guess what? It's accelerating. Something is literally pushing galaxies away from each other. But what? And the answer is both terrifying and exciting. Dark energy. It's the strangest thing in the universe, and we still don't know what it is. But we do know that dark energy is everywhere, and that means it makes up most of the universe. So how do we know that dark energy exists? Because we see its effects. Galaxies are speeding away from us, but that doesn't explain why. Enter dark matter. When people started researching the expansion of the universe, scientists had a problem. They couldn't explain how galaxies spun. They seemed to be breaking the laws of physics. But Peebles noticed something interesting. If there was some invisible stuff in the universe, stuff we couldn't see but that gravity could, maybe that could explain why galaxies spin. He thought it was worth investigating, and since then, scientists have found lots of evidence for dark matter. For example, we know that there's a huge amount of gravity out there that we can't see. It's warping space and time. We can actually see that effect on the light around galaxies. It's called gravitational lensing. The reason we can see it is because there's a lot of stuff out there that we can't see. Basically, galaxies act like bowling balls on a trampoline. They warp space and time, and we can see that warping. But again, this doesn't explain why. Some galaxies spin too fast. Some clusters of galaxies move strangely. There seems to be some invisible stuff affecting how things move around. It's almost as if someone put extra players on the trampoline. Dark matter, like dark energy. We don't know what dark matter is made of, but we do know that it's everywhere. In fact, it probably makes up a quarter of the entire universe. Now, you might be thinking, wait a minute, I thought you said 95%, not 25%. Well, you're right, I did say that. And it's true that 95% of the universe is invisible. But here's the thing, dark matter and dark energy are not the same thing. They're just grouped together because we don't know what either of them are made of. In fact, dark energy is probably not even real. It might just be a misunderstanding. Like when we look at faraway galaxies, it's like looking back in time. And what do we see? Baby galaxies. But baby galaxies shouldn't exist. They shouldn't have formed so quickly. So either the laws of physics were different back then, or we just don't understand them yet. But here's the beautiful thing. Whether or not dark energy is real, the universe is definitely expanding. And whether or not dark matter is real, the universe is definitely made of more than just normal matter. The point is that 95% of the universe is invisible. Only 5% is normal matter. It might seem depressing, but it's really not. Peebles never saw it as a bad thing that we don't understand most of the universe. He saw it as a wonderful thing. After all, our universe is unimaginably vast. We have no idea how big it is. And all we have to do is figure out what the other 95% is made of to learn even more about the universe. In fact, when Peebles won the Nobel Prize in Physics in 2019, he said this: "I want to say how much I've enjoyed being on this journey with all of you. The joy of understanding is far greater than any recognition." In other words, he loves the journey, not the destination. All of his life, he's asked nothing but questions. What is the universe really made of? Why do galaxies spin faster than they should? What is dark energy? Maybe we don't have all the answers yet, but at least we're asking the right questions. And that's all thanks to James Peebles. He basically invented modern cosmology. He taught us how to ask questions about the universe. And today, scientists around the world are following in his footsteps. They're building massive machines to try to detect dark matter. They're launching telescopes to try to understand dark energy. And they're doing it all because of one guy, James Peebles. He showed us that the universe is full of mysteries, but also full of answers. All we have to do is ask the right questions. Thanks for watching. See you next time.